Hello students, in the today's session we will talk about how to simulate the stop and wait protocol using the NS2. So there will be n steps. The first one is the creation of the simulator object. Second one is creation of animation file, that is the name object. Third one is creation of the nodes, because we have required nodes in order to perform the transmission of the packets, and creation of the link, creation of the sending data because of making of the agents, creation of the connection like attaching of the agents. So there will be two types of agents in the NS2. The first one is TCP and the second one is the UDP. Then start of application. Then if you are using the agent of TCP, then you have to start the application of FTP. If you are using UDP, then you have to start the application of CBR as our previous case. Then creation of the time allotment and the creation of the simulation run, and at the last you have to call the finish procedure. So at the previous example, we call the finish procedure at the third point, but still you can call the finish procedure at the last also. So we will do step by step. So first step is creation of the simulation object. So I will paste the same one. So how to create the simulator object? Like set, this is the command name, and what we are doing, that is set simulator, and it will be in the capital and letter the S. So my simulator will get created, and we can refer the simulator by using the NS object. Then we have to create the animation file. So for the animation file, what we have to do, for the animation file we have to set and file. The object is NF, and the command will be open stop dot name, because name is the animator file, and the access will be in the write mode, because we have to write the files, the contents inside the file, in order to make a animated creation, animated video something. So that's why. And we have to call the NS object, that okay NS kindly trace all of the do all of the tracing related to this simulator into this NF object. So this is very similar as per our previous discussion. And what will be the second step is already completed, creation of the animation file. Then what is my third step? The third step is creation of the nodes. So for the creation of the nodes, simple, you have to make a set and the node name is 0 and 0, because in the stop and wait protocol I am using only two nodes. So the first node is n0, and we have to tell the NS object, that is simulator object, that I want to create that node. So the command name is $ns and node, and the similar fashion I will create the second node, n0 and n1. So the third step is also completed. Then the creation of the link. So for the creation of the link, the same thing we have to do. Call the simulator object, that is hello NS, kindly create the link of node n0 and n1. So each time I have to create the duplex link, such that both the senders and receiver can communicate with each other, and between the two nodes. So what are that nodes? That is n0 and n1, and the parameters. So in this case I am doing the 0.2 Mbps bandwidth and 200 ms delay, and it will be drop tail, right? And the creation of the link, we have to do some optional parameters also, like the orientation. So for the orientation I am just taking the two nodes. So the second node will be orient right. So in this case I have to tell the NS object that hello NS kindly create the duplex link, and with position So with the difference of n0, the n1 should align with orient right. So I think these are pretty clear to all of you, because we already did these things in our previous examples. Now also in the creation of link, because we are simulating the stop and wait protocol, and the stop and wait protocol is using the reliable communication. So what is reliable? Basically, the reliability means if a sender wants to transmit something, then sender has to ensure my packet is correctly reaches to the destination. So that is called the reliable point of view. And where the reliability comes, there is one point also comes, that is called the connection oriented. So always the reliability achieved by using the connection oriented protocol, and the connection oriented protocol is nothing but the TCP, and the connection access protocol is UDP, because stop and wait is the reliable protocol, that's why it uses TCP instead of UDP. So if it uses a TCP, then you have to set the queuing size also. Queue limit. So the link between the N0 and N1 can carry up to 10 packets. Okay, that is the meaning. Now the fifth one is creation of the sending data, means we have to create the agents. As I told you, we are implementing a stop and wait protocol, and it is a reliable communication protocol. So flow control policies is there, so that's why we have to use a TCP. So if you are utilizing the TCP feature, then you have to set TCP agent. So my agent name is TCP, and for the creation of the command is new agent. So in case of UDP, you have set UDP here, but I'm creating TCP, so I will put TCP here. And also one thing is, because we have to trace all of the communication that is performed by TCP, and the TCP is more rule oriented protocol, that's why we have to take a permission from the TCP before tracing all of the values. So we have to make one thing, that is agent is of TCP, and we have to make one boolean type of variable, that is name trace var, and its value should be true. So if its value is true, then all of the tracing that is performed by the TCP communication will get true automatically. Now also after the creation of the agent, we have to set certain parameters for this TCP, because UDP is connectionless and there is no so much complexities over there, but the TCP, it says so many protocols are there, that's why we have to make certain settings. So some settings are the TCP $TCP, because we have already created that object, and now I have to refer that object in whole of my program by using the $sign. So $TCP set window size. So window equal to 1. What's window size? So window size is nothing but the sender and receiver window, that at a particular time how much sender and receiver can send or receive the packets. And TCP set congestion window size, maximum congestion window. So max CWND, congestion window size, and it is also 1, because the limitation of the stop and wait protocol is we have to send only one packet at a time. So the congestion window should be not more than 1. That's why both the window size and the maximum congestion window size is allocated to 1. So now I think is clear. Then the next step is we have to create the connection, the 6th step. So for creation of the connection, we have to attach that agents, right, in terms of the sync as well as the destination nodes, right. So for attaching all the agent, what we have to do, first we have to call my NS object, that hello NS. You have to 1 second. What we have to do here? Okay. So hello NS, kindly attach the TCP agent into my sender node. So what is my sender node in that case? So my sender node in that case is M0, and what is my TCP agent object? That is $TCP. So regarding this, it will get attached to $M0 and it will be act as a sender. Now this is the sender node, and again we have to create one destination node. So like set, for that I have to just paste it over here, like set and sync. And what is my object? Here is new command name agent, and for making the destination I have to use TCP sync, TCP and sync. So only TCP is attached to the sender node only, and the TCP sync is attached to the receiver node. I have to attach that agent into my node 1, and it is sync. So my agents are attached, the sender agent and the receiver agent with the corresponding node N0 and N1. For performing the communication, I have to attach these nodes also. So how can we do that? We have to use the connect command, like $ns connect and $tcp attach with $sync. Yeah. Now the 7th one is start of the application, because I'm not creating any application till here. So that's why I have to create one application, because I'm using the TCP. So that's why we have to create the TCP related application, and TCP uses FTP as an application and UTP uses CPR. So one application I have to create, that is FTP. And what should be the command? The command will be new and application. Which type of application I have to create? Application I have to create FTP. Okay. Then after the creation of the application, I have to attach that application over the sender node, right? So for that, I have to attach $FTP, and the command name is attach agent and $TCP. So for the $TCP, my FTP application will get attached. And also one thing is remaining, that is tracing all the files. So it is under the application, so that is FTP and add agent trace and $TCP and TCP. So what this line wants to say, this line is wants to say that the tracing files that is created by the FTP, it should be traced according to the addition of this agent, that is TCP. That's why. Now there is one thing that is called the monitoring. So it should not be, actually it should be NS, because I am give the order to the NS object. Then NS monitor agent trace and $TCP. And one more thing, that is $TCP, the congestion window variable, that is traceware CWND. It starts from there. So it is little bit confusing. Actually, after creation of the FTP application, we have to attach the agent. So my agent is TCP here. After attaching of the agents, I have to invoke the trace also, because I have to take the permission from the TCP. TCP is not utilizing and not give the permission to anyone to trace their files. That's why I have to add agent regarding the TCP. So TCP से related जो भी मेरे nodes होंगे और जो भी वो sender या receiver packet send करेंगे वो trace हो जाएगा, and we can monitor that tracing. That authenticity have to be taken from my NS. Then also all of the things will get it true under the trace variable, that is congestion window underscore. So that is the necessary things that you have to invoke under the FTP application. Now what is the another one? The another one is creation of the time allotment. So for the creation of the time allotment, what we have to do, then $NS at 0.1, my FTP will get start. And $NS at 3.0, $NS detach agent $N0 and $TCP, because TCP is related attaching to the node N0, and colon we are actually detaching, means we have to remove the communication. That's why. N1, and what was that object related to the N1? The agent was sync. So at 3.0 all of the communication will get stopped, and all of the agents will get detached from N0 and N1. And after $NS at 3.5, it will invoke the finish procedure. Right, so what is my finish procedure? The finish procedure is proc, like the procedure function, and finish global. What are my agents? There are two agents, there are two objects, NS and NF, and I have to flush all of the tracing points such that I can restart the simulation with a fresh environment. That's why I have to flush all of the previous tracing that is done by the simulator and close $NS, and then puts running name. It is optional. Then execute. Name. What is my name object? Name file, sorry, that is stop.name, and exit 0. So it will be automatically enable the name file, animator file, and your animation will get started. And the last one is the running of the simulation. So it should be, I think, in the last one, and it should be in the first one. So it is 10 and it is 9. So my program is completed and I have to run it. So for there I have to save it, cross it, and running the command ns sw.save. So my name animator is open, and oh, I think it is another program. One second, guys. So for the more animation, I have to create the labeling over here. So ns, and what is my label name? At 0.0 $N0 label sender. So actually I am renaming my node N0. I am giving the name to my N0 node, that is sender. So it will be under this one, and in the same way I have to create for the N2, but in place of the sender I have to make it as a receiver, because my node N1 is a receiver here, right? So my labeling is completed. Also I have to do some more annotation. For this annotation, after calling the finish procedure, like $NS at 0.0 time when it starts the simulator, then $NS tracing. For the tracing I have to annotate it for the better understanding point of view. So annotate, and what should it say? That is stop and wait with normal operation. It is optional, so if you want you can do it, otherwise it is not needed, but it becomes more beautiful when it runs the simulation. That's why I annotate it, and for the reader it will be more efficient to understand the things. And $NS at 0.05 seconds, $NS trace annotate, so at 0.05 second my application will get started. So I have to write over there, that is attribute starts at 0.1. right? And then second one, ns at 0.11 seconds, $NS trace annotate, and send packet 0. So receiver is sending packet 0 over there, and after transmitting the first packet, it has to receive the acknowledgement. So at 0.35 I have to annotate, and it will be receiving the acknowledgement. So in case of the send packet, I have to take receive ACK. ACK for what? ACK for 0. So sometimes it is written that acknowledgement should carry the sequence number of the next expected packet. If you want, you can do it, but for the understanding point of view, I am taking the same sequence number, that after getting the packet 0, I am sending the acknowledgement with the same sequence number. So like the same way, I have to do it for second packet transmission. So obviously it will get 0.56 over there and send packet 1. If it is 0.56, then it will be 0.79 and acknowledgement packet 1. And like the same way, I have to do it for all of them. So I written the annotation code for all of the packets. If you want, you can add more packets, but accordingly you have to increase the time also, because my simulation will be getting finished from 3.5. So make it 4 and 5 or 6, and you can start to sending more packets and receive the acknowledgement. So it is up to your choice. And $NS, the last one is at 3.1, because at 3.5 my simulation will get stopped. So for the safety point of view, I am stopped my FTP packets, stopping the FTP packets at time 3.1. So please annotate FTP stops. Right. So now we can run and see how it is look after the annotation. So you can see it is more looking beautiful now. So until I stop here. So sender and the receiver, it is labeled. So the reader can actually visualize that which one is a sender and which one is a receiver. And also if we start it, you can see in here FTP starts at 0.1. It is sending packet to 1 towards the receiver. Then after receiving, the receiver sending the acknowledgement to the sender, and sender receives it. So it sends you the message that receive acknowledgement 1, and in this time sender is sending packet 2 and receiver is sending the acknowledgement 2. So like this way, all of the things can be better visualized by using this annotation part, that which one is the sender, which one is receiver, which packet is going on, which packet the corresponding acknowledgement is received by the sender, at all of the things. So like this way, you have to implement the stop and wait protocol. And the second part is called the sliding window protocol. So in the sliding window protocol is, what is the difference? The sender and receiver are only allowed to transmit one packet at a time, but the sliding window says, in order to achieve the maximum throughput and the better link utilization, the sender and the receiver can take more than one packets, can send more than one packets. So the sender window size and the receiver window size should not be 1 in case of the sliding window protocol. It should be greater than 1. Sometimes it get 4, 5, 6 and 6. You can situate according to your own choice and implement the same thing in the sliding window protocol, like the sender and receiver acknowledgement, two nodes are there, as well as the TCP and FTP applications are run over the sender and the receiver. But the only difference is you have to maximize the sender window size and the receiver window size. So in the code I will explain you that where you have to do the modification. So I will start get edit again. So in the get edit here, yeah, in that case window size and the maximum congestion window size, it should not be 1. In case on the sliding window protocol, it should be greater than 1. And also you have to modify these things also, because you cannot transmit only 0 packet at a time. If you are transmit 4 packet at a time, then you have to mention it 0, 1, 2 and 3, and receiving the acknowledgement for 0, 1, 2 and 3, like this way. And the next packet will be 4, 5, 6, 7 and receiving the acknowledgement of 4, 5, 6, 7. So in that way you have to implement the sliding window protocol. So I think it is pretty clear to all of the students. If anyone has a doubt, kindly mail me. Okay, thank you very much.